Some question for upcoming JEE Mains. First question is from Electrostatics Gauss law. E is given as E naught x I cap plus E naught y is j cap. You need to find out the total flux or total charge inside the cubical volume. So let's assume these are axis x, y, z. So this is basically a cube of edge A, and these are the sides faces given 1, 2, 3, 4 and 5. The sixth face is not given, so I am assuming the front face is sixth. The front is sixth one. So E naught x I cap flux due to this component. For flux due to this component, the areal vector should be along this one. So area vector of 1 and 3, the area vector of 1 is along this one, x-axis. That means as it is E naught x I cap, the electric field is along I cap direction, that means along x-axis. So area vector will be along x-axis only. So this one, and for this one. So for E naught x I cap, so this one, this area vector, now this is the area vector. Now E naught x, value of x is 0, so the electric field is 0 at this point, so for this flux will be 0. Now for this one, this will be E naught x I cap, again value of x is a, so E naught a I cap, and the area vector is a square I cap, so that is E naught a cube. That's all. For the 2 and 4th phase, these will be responsible for again the flux. Here the value of y is 0, so flux will be 0. Here it is E naught y, y value is a into a square j cap into a square j cap, as area vector is along this direction. So that will be E naught a cube. Total flux will be the sum of this one, 2 E naught a cube should be equal to q by epsilon naught. Hence q will be 2 E naught a cube into epsilon. That is your option B. In this question, a particle is in uniform circular motion. The equation of its trajectory is given as ट्राजेक्टरी इक्वेशन है कि x माइनस 2 स्क्वायर प्लस y स्क्वायर इक्वल टू 25, that is 5 square. So from here you can clearly see that the 2, 0, that is the standard circle equation, y minus 0 square, you can write this one, is its center. So that will be 2, 0 means this one, and its radius will be 5. So you can write that, let this one be the, this is 2, 0, this is 7, 0 minus 3, 0. So acceleration will be v square by r. V is 2 square by r is 5, 0.8. Acceleration will be along this direction, 0.8 minus j cap, as it is in uniform circular motion. At here the acceleration will be along this direction. The acceleration will be along this direction, 0.8 plus j cap for this one in this direction towards the center, for this one in this direction. for this one in this direction. So at all point you can find out the acceleration along with this direction. There is a question given: a point charge q is placed at a distance r by 3 from center O of an uncharged conducting hollow sphere of inner radius r and outer radius 3r. So you need to find out the potential at the center. As this, due to this q, there will be a minus q charge induced in inner side and plus q charge will induce in the outer side. So for this plus q charge, the potential at the center will be kq by 3r. For the minus q charge, that will be minus k into minus q by r. And for this q charge, that will be kq by this distance. This distance will be how much? R by 3. So it will be kq by r 3 plus 1 by 3 minus 1, that is 2 plus 1 by 3, that means 7 by 3 kq by r. This will be this question. I think we did in some of earlier videos. Two identical point dipole have dipole moment p1 is equal to pi cap, p2 minus pi cap are held on x distance at a distance a from each other. When released, they move along x-axis in the direction of the dipole moment, remaining unchanged if the mass of each dipole is something in the speed when they are infinitely far apart. So let's assume here is pi cap minus pi cap. They are in this direction. They are at a distance a. The potential for this arrangement we did in our class lecture 2k p1 p2 by r cube. This is initial potential energy, and final potential energy as they are infinitely far apart, that will be 0 plus half of mv square into 2. That means you can clearly find out p1 p2 is equal p square. So you can clearly find out p by a to 2 by 2. You can write k as 4 pi epsilon naught. So 1 by 2 pi epsilon naught ma. Moving on to the next question. So in this question, you need to find out the capacitance of the capacitor. Let's take a distance x from end. So these two capacitors are in series. So for the first one, that will be C1 equal to epsilon naught a by d. Area is given. So as this is square plate, so the area will be a square epsilon naught a by d. This distance you may write d minus. Let's say this is x. So if this is x, you can take this is theta. So this will be x tan theta. So this distance will be d minus x tan theta. And you can write tan theta as this one is a. You can write tan theta as from this triangle d by a. This will be c1 and c2. Area will be a into dx. Now these are in series. That means 1 by c equal to 1 by c1 plus 1 by c2. So you can write this one as c equal to 1 by c equal to 1 by c1 plus 1 by c2. 1 by c1 is this much plus 1 by c2 is this much. This is your c2. So this d minus x tan theta will go upward. This will be d minus x tan theta, and this one will be x tan theta. This will be 1 by c. So if you solve this one, this 1 by dc equal to 1 by c1 plus 1 by c2. 1 by c1 you can write this one and this one from here. Now I'm just simplifying this. So this is dc. Now c equal to epsilon naught a dx by d plus x tan theta 1 by k minus, and d plus x 1 x tan theta 1 by k minus 1. You can write this one as epsilon naught a ln d plus x. Integration of this one will be, this is simple thing, here it will be tan theta 1 by k minus 1. Now just put the limit 0 to a. So this one will be epsilon naught a tan theta is, you know that tan theta is d by a. So from here you can clearly write d by a square 1 by k. You can write this one is k into 1 minus k. Now if you put this ln term, just d plus a tan theta 1 by k minus 1 minus ln d. Tan theta can be written as d by a, so a get cancelled out. So this is like d plus d by k minus d. So d plus d by k minus d, this is also cancelled out. Now you can write this ln d by k minus d as minus ln d. You are getting this one. So this you can write ln d minus ln k minus ln d. Log a by b is log a minus log b. This is cancelled out. So you are getting minus ln k. And if that minus is multiplied with this one, you are getting the final result k epsilon naught a square by d into k minus 1 ln k. There is a solid conducting sphere having a charge q is surrounded by an uncharged conducting hollow spherical shell. Okay. Let the potential difference between the surface of the solid sphere and that of the outer sphere of the hollow shell be V. Let the potential difference between the surface of the solid sphere, that of the outer sphere of the hollow shell be V. Okay. This is having a charge Q. The potential difference between these two is V. The shell is now given a charge minus 4Q. Now then the new potential difference. Okay. So let's assume initially the potential difference between these two one. This is having let's say this is having some radius r1, this is having some radius r2. So at the surface the potential will be kq by r1. At this surface this will be kq by r2. This was the initial condition. Now it is given a charge, or rather you can write, if this is having charge q, this one will be having minus q, this one will be having plus q, but the net effect of minus q and plus q will be cancelled out. So this will be the initial potential that is given as V. Now cell is given a charge minus 4q, so the charge will be kq by now we need to find out the potential. So for this q, potential at this point will be kq by r1, and for this minus 4q, the potential at this point will be k into minus 4q by r2. For this q, potential at this point will be kq by r2. For this minus 4q, potential at this point will be this one. If you subtract this one, so you are getting kq by r1 minus kq by r2, and these two cancel out. So the potential again becomes V. The potential is not changing in this case. There is a question from gravitation. A person whose mass is 100 kg travels from Earth to Mars in a spaceship. If he travels from Earth to Mars in a spaceship, so first somewhere in between them, G effective should be 0. And initially the person was getting attracted by this one. Later on he will be more attracted by Mars. Now neglect all other objects in the sky. Take acceleration due to gravity on the surface of the Earth, and mass is 10 meter per second square. This is 10 meter per second square in both the surface. Mass is 100 kg. Now you need to show 10 meter per second, and this one is 4 meter per second square. You need to show which one is the best fit for the weight of the passenger. So here the maximum weight will be how much? 100 into 10, that is 1000 Newton, and the maximum weight will be 400 Newton. Okay, so as this is a graph of gmm by r square, and at some time g effective will be 0, so within option a, b, d, a is a straight line, which can never happen because it is inversely proportional to 1 by r square. Between b, c, d, you can clearly see that for c, g effective is 0. For c, g effective is 0, means somewhere in between them, the value of the weight should be 0. So that's why option C will be your correct answer.